Hello, I'm Keith Swenson, and this presentation is to help clarify the spectrum of approaches that are available for supporting business process-like activity. Others have attempted this, but my approach is based on comparing the amount of predictability of the particular business problem being solved. Using predictability, we can identify 7 different technological approaches that are in regular use today, and picking the right one is important. Let's start with the overview and the big picture. The setting is that we want to produce a system to support people doing work. Since the beginning of the information revolution, you've always had 2 extreme possibilities: application development and no development. On the left of this diagram is an application development. This refers to the traditional programming techniques. You hire a programmer or a development team, maybe a system architect, maybe a user interface designer. What results is a custom application designed for a specific purpose. Such an application can still support a business process. The process is coded into the program logic directly, and changing the process requires reprogramming the application. On the right, you have the no development option. One worker can send an email to another worker asking for help or delivering a result. Texting, instant message, and telephone calls fall into the same category. There's no pre-programmed coordination of the activity. There's nothing in the system at all about the process. It's an entirely manual in the sense that each action has to be a deliberate decision by the people involved in the interaction. A person decides to contact another person when they wish, however they wish. Now on the left, the traditional application development paradigm allows for the most powerful support for coordination. Almost any interaction pattern can be scripted, enforced, monitored, but it's expensive to develop and expensive to update when your business changes. On the right, there's no programming of the coordination, and so beyond the initial infrastructure, it costs nothing to prepare a new business process. But it puts the burden of knowing and following the process completely on the users. They must be more aware of the process, possibly trained, and there will be mistakes, retries, and patching up done while working. Predictability of the process determines how much return you are likely to get on an investment. A very predictable, repeatable process will produce a high return on investment. Consider a factory, a company that can define exactly what mechanical actions are needed in order to make a manufactured process, can invest millions or even billions of dollars into a factory, to which then turns out products cheaply. A massive investment requires a massive scale in order to pay back the investment. The same is true with software in the collaboration system. You only make a large investment if there are going to be a large number of cases or if each case is valuable. The less predictable a process is, the less you want to invest. When a process is very hard to predict, and when you need thinking people to make decisions on what to do next, using the basic communications model, you would save on the investment, but of course the trade-off is there's a larger burden on the workers. The broad field of process technology fills the gap between these extremes. Business processes constantly need change and improvement. Organizations need some sort of support to make sure that their processes are being done consistently. But you can't always afford the heavy investment in a custom programming job. The goal of process technology, then, is quite simply to offer a way to get support for a process that is less costly to implement and less costly to change. This process technology was originally called workflow in the 1990s and later BPM in the 2000s. What we are seeing now is a spectrum of process support technologies. All of them claim to support flexibility for processes as well as incremental improvement, but each technological approach has different affordances for supporting flexibility, as well as differing levels of power at being able to control the process. We can organize these technologies into an ordered spectrum according to predictability of the work situation they ideally support. On the left, you have the most powerful capability to precisely define and control processes, at the same time the most cost to implement. As you move to the right, it becomes easier, less costly, to implement and change a process. But your power to control the process also decreases until you get to the far right, where there's no upfront investment and basically no ability to control the process. Remember, it is predictability of the business problem that is being considered. If the work itself is highly predictable, then you can pick a technology to match. If the work is entirely bespoke, then you'll pick a different technology to match. Clearly, the more predictable the work is, the more benefit you will get from proper process support. The further to the left you are willing to go, and the more investment you will make and still get a positive return on investment. At a high level, let me introduce you to the 7 domains. On the left, you have traditional programming, as discussed. Right of that is process-driven server integration, where you use a process diagram to coordinate information being passed between systems when you need to accommodate those systems changing every now and then. Next, you have human process management, which takes a strong process orientation but adds capabilities to deal with the unpredictability caused by assigning tasks to humans, such as reminders and escalations. Next is production case management, where the process is less fixed and the user decides at runtime what to do next from a menu of possible actions. The menu is fixed, but it's case management because the user decides what is best at runtime. To the right of that is adaptive case management, which is like PCM, except that the user can decide to put new actions on the list of possibilities at any time in order to address problems which were completely unseen at design time. Next comes social business systems, which is actually very little support for process, or some basic predefined interaction patterns, as well as a collaboration model with role-oriented access control. Finally, on the far right, the complete and utter lack of predefined process. You throw up your hands and submit to manual email mode. You'll notice that the dominant ways information is structured changes as well, as indicated at the bar at the bottom. Let's take a look at each domain of predictability in detail. Traditional development is the most powerful. In a third-generation language, you can implement literally any process. The process state is held in variables or a database column, and hand-coded logic can change this state at any time in any way needed. Any user interface can be exposed at any time in the process. Programming the process requires a trained programmer, and making any changes does as well. This programming can be quite tricky, even for an experienced programmer. It's easy to make errors, and so a lot of debugging and testing is required. When thinking of actual real-world examples of this, I usually think of a factory floor or a fast food restaurant. In a burger joint, you know those cash registers that automatically send your order to someone in the back. Or programs for custom machinery to perform specific manufacturing step. Both of these cases will be run many, many times exactly the same way, and the process is more or less completely predictable and under control of the organization. The high predictability and the high numbers of cases can justify a high initial investment to get the process exactly right without any limitations. The second domain is quite similar to this in that you have a completely automated process, but I call this process-driven server integration because it has to do mainly with coordinating the work of many separate systems. Consider the example of a phone company when somebody buys a phone. You have to access one system to allocate a phone number, another system to set up an account, another system to order the phone, another system to arrange for delivery. This is called a business process because it's a key to getting business done and it spans many separate systems. The challenge here is first to make sure that all the right updates are being done to all the right systems, and doing this via a process diagram is a big benefit. PDSI systems invariably have some way to model the process, and that's how you distinguish them from traditional programming. This process model helps to structure the code in a way that makes it easier to cope with change. For example, when your system to track user accounts is changed, it is relatively easy to change the process at that one step and be relatively assured that nothing else in the process is broken. If the market changes, as it did when SIM cards were introduced, it's relatively easy to add a step to call the new system for ordering SIM cards and still be relatively assured that the rest of the program remains unaffected. The process model formalizes the communications between systems in a way that makes it easier to change. The PDSI models are dealing with low-level data, picking up a record from one place, transforming it, sending the result to another place. The modeling must be done by a programmer who understands data structures and transforms, although a business person might be able to review the model for conceptual correctness. Straight-through processing fits into this category. In 2003, there was a lot of hype around BPEL, Business Process Execution Language, being the unifying standard for BPM. Actually, BPEL is an excellent example of this category since it offers a process model which sends and receives information to and from web services. BPEL has a concept called a participant, but that participant must be a web service, which was considered misleading by people working in more human support fields. Process-driven server integration is, at the high level, a form of programming that uses process models to gain additional flexibility to cope with changes in the distributed environment. Even so, such changes are usually planned weeks or months in advance. Then there's a domain that is slightly less predictable than PDSI, and that is human process management. Here again, you have a process map. But while in PDSI, the map is showing actions to send and receive information from servers, in this domain, activities are assigned to people. Humans are in many ways less predictable than servers. In PDSI, the process will decide which server to handle a task. It'll send the request, and 99.95% of the time it will be done. However, for humans, it is not uncommon for a task to be assigned to one person and then reassigned to another and then forgotten about until a reminder is sent and then finally completed by someone else who works with the assignee. Human process management has to be designed to support the idea that you can't state in advance exactly who will do the task. Usually this technology has strong support for roles, which is a way of indirecting the assignment to a structure that can be easily changed from day to day without having to edit the process itself. Another aspect is some form of task list so that humans can pick the best thing to do at this moment from the rest, as well as deadlines to help indicate that something has been sitting too long and reminders to proactively prompt for something that's late. There is usually an escalation feature that allows tasks to be automatically reassigned if it takes too long. It is worth noting that none of these features are needed in the process-driven server integration domain. If a server fails to respond, then sending a reminder will have no effect. A good example is an expense report handling. There's a number of people involved who do different tasks like approving and checking. There are reminders if people are slow, and tasks can be reassigned if someone changes positions. Human process management must be much more easily changed in the face of market changes, business changes, or personnel changes. People are changing positions within the organization every day. Often the process will need modification to fit the skill of a particular subunit, since human skills are not as precisely defined as computer programs. In general, the process modeling has to be at a much higher level with much less programming involved. That means you can't control the process to the same degree as you did in PDSI. Production case management is more flexible still. Here, the process itself cannot be completely defined in advance, yet we can define a set of possible actions that one might want to do. We cannot automatically determine what to do. So the user has to decide, based on experience, what the right thing next to do. A good example is a Helpdesk or customer support center. In this case, there are a set of possible actions, such as refund the customer, or order a replacement, or escalate to development, etc. Mostly, the customer support agent answers questions, but if warranted, can call one of these steps into play. The agent is a knowledge worker who learns the specific trouble modes that people are likely to encounter and learns to determine the right course of future action for each case. We call it production case management because it's designed for high-volume situations. I call this knowledge workers for hire as opposed to knowledge workers who own the case as a business. So if you have a 30-person or even a 100-person customer support department, the actions that those users will take will be defined and provided by a development team. And the user will not have any ability to add new actions to the set. Like human PM, there is a separation between the people who determine the possible actions, the developers, and the people who use actions, the users. The next category is adaptive case management, and it's even less predictable than production case management. You not only can't predict the process, you can't even predict all of the actions that you're going to need in advance. Now, of course, regular actions are known in advance, but there exists a significant number of cases where a new action will be needed that has never been done before. In some cases, this is a unique action that will never be done again. A good example of this is a doctor. Much of what a doctor does is routine, but diseases are complex and the symptoms are not always clear and unambiguous. There are cases for every doctor, every day, where either the symptoms are unusual or there is a new treatment available that has not been tried yet. The doctor might research a bit and discover a new drug that studies show is promising in this particular combination. The doctor needs to be able to, at that moment, draw up a new treatment plan for this patient, possibly doing things that have not been done by that hospital before. He can't wait until the end of the month for a programmer to update the software. He usually can't even wait till the end of the day. To be completely clear, most doctors today use no process support. They simply type a text description somewhat equivalent to an email message. The reason that process support has evaded professional fields like doctors is because so many different processes are needed that cannot be known in advance. That any technology to the left of adaptive case management would simply be too costly to use. ACM offers an approach that is very, very easy to create and modify processes so that individual knowledge workers can modify them for one-off situations. This means that essentially no programming can be used within the process because any programming there would be a barrier to allowing the knowledge worker to change it. It seems that what we call a process here starts to look mostly like a simple checklist. Most of the information is in documents or PDF reports and in quick notes. Going from left to right, ACM is the first domain where workers are asked to sit down and plan what they're going to do to complete a case and to create a list of goals to accomplish that plan. And that makes ACM different from everything to the left of it. There is room for one more domain between ACM and email. This is a domain that has very little or no process customization to it. However, there's a greater amount of collaboration and time sequencing than basic manual email. This domain has people collaborating on permanent artifacts and often uses network connections to control access. The best example I have of this category are domain-specific cloud applications to support specific collaboration scenarios. For example, Eventbrite and Evite are cloud services to help you coordinate a meeting or small event. You create an event record, specify the date, and then invite people. A notification is sent, and then those people can indicate whether they're coming or not, and a tally is kept. As it comes close to the event, reminders are sent out. This is the process aspect. And there's often a place to share documents. For example, sometimes these systems allow you to declare some people as presenters, that's a role, and presenters can upload their presentation slides to share. Content management systems basically fall into this space if they offer some sort of role capability that can be used to control access to sets of documents. Content management systems usually have some form of review or approval process. However, many such systems call themselves content management may actually have quite strong process support, qualifying them for ACM or human process management. The term social is included here because there's an increasing trend to allow these spaces to be self-defined and to allow people to make use of networks of connections for controlling access. I'm not saying that Facebook necessarily falls into this category, but rather there are social features that help make this category distinct from plain old email. And that brings us to the domain that supports the most unpredictable, and that is simply email or other direct communication technologies. What really distinguishes this category is that you write something and send it. There's no permanent structures, no collaborations. People can reply, but that's nothing more than a new email. This domain will never go away. There will always be the need for direct, unconstrained communication, e.g., I'm running late for a meeting, or here's an interesting article about a product, or oops, I accidentally rejected that purchase order. Can you resubmit it? There are many, many human activities that are simply not repeated enough to make an application specifically for them. These actions may be used only once. There are two disadvantages of this category. The first, of course, is that the user must manually implement any proper protocol, and that depends on expensive training. The second is that the record of what happened in running the process is either missing or much less useful. Many things are handled this way that really should be in the future handled with a better domain. If the work is to some degree predictable, then using an option to the left will be an advantage. Now note two things. In all of these, I did not use the term BPM, Business Process Management. That term is not well defined, and there are people who will vigorously defend that BPM means one of these domains, or another of these domains, or sometimes all of these domains. My advice is that when someone mentions BPM, you try to determine which of these technologies they are particularly referring to. Second, I did not fall into the trap of saying that processes are defined to some level, but then when an exception occurs, you switch to another category. In any of these categories, there will be the need to occasionally send someone email to fix a problem or to handle a case that does not fit perfectly. In each domain, I gave an example of work that was itself inherently predictable or unpredictable to differing degrees. I didn't conflate the idea of predictability with the idea of exception handling. There will always have to be exception handling, but the normal, non-exceptional work, the examples I gave in these domains, were inherently predictable to varying degrees, and it's that normal non-work that predicts the technology that you should use to approach them. So in summary, at a very high level, on the left we have application development, custom traditional application, very powerful but expensive. Process-driven server integration is easier to implement a process, easier to change, but still mostly programming. Human process management adds the ability to support things, particularly for unpredictability of humans. Production case management is now unpredictable processes where the actions that you might take are fairly predictable and where those actions are defined by developers separate from the users. Adaptive case management, where the actions you want to take are constantly changing and must be modified by the users themselves. Social business systems, where you have not a really strong process coordinate. You don't have planning in there, but you do have some scripted processes and some collaboration-oriented things that are used in accomplishing business. And finally, email, texting, Twitter, telephone, the category of unscripted, unpre-programmed processing. When discussing categories with people, be aware that most vendors will claim to support many or all of these categories with a single product. Be skeptical. In many cases, the quality of one domain cancels out a quality in another domain. I'm not saying it's impossible to cover multiple domains. Indeed, the bigger systems accomplish this. But to do so requires that they have a specific mode for implementing a particular domain. Be very wary of any system that says it has email and it has processes that can be changed by anyone, so it has unified all these domains in a single product. It's not that easy. So I hope this has given you an idea of how there are different domains of predictability for which different technological approaches are appropriate. For more information, please check my blog where you'll find many more details on these topics and others.